Hey everybody, it's Mr. Mac. Today we're going to be looking at Newton's first law of motion. Now, Isaac Newton, famous physicist, back in the late 1600s, came up with three laws of motion that we have been benefiting from ever since. Today we look at the first one and its implications in our day-to-day life. So we've got two videos here, one of a baseball, one of a soccer ball. The baseball's initially moving. The soccer ball is initially standing still. Both of them are obeying Newton's first law of motion. Now, our textbook definition of this is an object in motion will stay in motion. An object at rest will stay at rest. Unless, and this is the key, unless it's acted on by an outside force. Can you see the outside forces in each of these situations? Well, just as a reminder, a force is simply a push or a pull. When you look at the baseball is initially traveling in a straight line toward the batter at a constant speed. The motion is constant. Now, the batter supplies a force, the push of the bat against the ball. And by doing that, we change the direction of the ball, and we probably change the speed of the ball too. Now, with the soccer player, the ball was initially stopped. It wasn't moving at all. It was an object at rest. The soccer player comes along, supplies a force, a push, which is a kick, causing the ball to speed up and move in a certain direction. So again, both of these are examples of Newton's first law, very basic definitions. All right, now one of the definitions, vocabulary words that we have to use with Newton's first law is inertia. Pretty simple little idea. Inertia is a property of matter. Matter is what makes up the entire universe, your body, a baseball, a soccer ball. So it's a property, and what it does is it makes it harder to change an object's motion. So what does this mean? Well, let's take a look at the example below. We've got two kids. They're both pushing an object. One's pushing an empty cart. One's pushing on grandma on a cart. And one of them is not going to be able to change its motion as easily. The boy pushing the small empty cart, he's going to supply force, and that cart's going to immediately start moving. It's going to speed up pretty quickly. The boy pushing on grandma is going to push with the same amount of force, but grandma's going to speed up slower. So that's a reaction of her having more inertia. So where does inertia come from? Basically, it's a measure and directly related to your mass. How much stuff you're made up of. So if you've got more atoms in your body, you've got more inertia. So keep that in mind. We want to talk about what it actually means, though, to change the motion. The boys are pushing on the cart and grandma, and the motion's changing, but not as much on one as the other. When we talk about change in motion, we're talking about a change in an object's direction or its speed. Those two things together constitute your motion. So with the girl below on the motorcycle, we can see she can speed up or slow down. The engine supplies a force to make the motorcycle go faster. The brakes on the motorcycle supply a force to slow it down. Now, if she jumps a hill, the ground is actually pushing up against the motorcycle when she goes over it, and it changes her direction. So she's actually, in a way, changing her speed in that direction. She wasn't moving upwards initially, but now she's sped up in the upwards direction. So that's a change in her motion. So keep that in mind. That's a fine point. We'll be talking more about that in future units. Now, car crashes are some of the best examples of Newton's first law out there. As you can see, there are crash test dummies in here, and the car undergoes something different than the dummies. Now, when the car hits the barrier, it stops, but the dummies inside keep moving forward. Eventually, they hit the airbag, they hit the steering wheel, they hit whatever is in front of them, because Newton's first law says they're in motion. They stay in motion. Now, this guy's invented a little gun that actually shoots Jenga pieces out of a big pile. But if you notice, all the other pieces are not affected. Why is that? Well, the force of that gun is only being applied to the single Jenga piece. It's not being applied to the entire pile. So when he shoots one, only that one's affected. Everything else stays in place. Finally, one of the oldest tricks in the book is pulling the tablecloth out from under a table. Why does this work? For the same reason. The person pulling on the tablecloth is only pulling on the tablecloth, not everything else. So in all three of these situations, everything's obeying Newton's first law. If they're in motion, they stayed in motion. If they weren't moving, they stayed at rest until some outside force, some kind of push or pull, caused them to change their motion. So I hope these little videos helped, and we'll see you on our next podcast.